Welcome again to part 17. This video is short. It sets up a simulation with the results of the simulation in the next video. With the 9 scenarios defined, some attempts should be made to see if the conditions derived will add up to the predicted result. To test the scenarios with simulation, the following procedure was used. For each of the 9 perturbation risk ratio scenarios, the same ideal market conditions were held constant. That is, for each perturbation risk ratio, the following parameters from example 13.1 held. The ideal betas were set as follows. The low ideal beta is 0.5, the high ideal beta is 1.5. Average excess return is 10%, average perturbation return is 0%. The ideal risks were set as seen here in example 13.1. The sum of the perturbation risks is set to 20%, which will be explained momentarily. The specific levels of the perturbation risk ratio for each condition were set as follows. The specific levels were set to satisfy the 9 conditions of the 9 scenarios. The conditions in table 17.1 are the same as in table 16.1, with the only difference being that specific numerical values are set for the perturbation risk parameters. Whenever there is an equal sign in the condition column, the value of the perturbation risk ratio is set by that condition. Whenever there is a greater than sign, the value is set to be arbitrarily consistent with the condition. Using Microsoft Excel, excess returns for an ideal market portfolio were generated for 30 time periods using an expected mean excess return of 10% and standard deviation of 18%. This was performed for each of 30 time periods using the Excel function shown here at the top of the page. Only 3 time periods are shown to demonstrate the method. The returns for the ideal portion of the high and low CAPM beta portfolios were directly calculated by multiplying the ideal market return each period by its respective ideal beta. Similar to the random process that generated the ideal market returns, the series of perturbation returns with 0 expected mean were randomly generated for each of the ideal portfolios. The parameterized sum, which was set to 20%, was then divided up between the 2 perturbation risks in such a way that the parameterized ratio between them is set before the random process is carried out. The 2 sets of perturbed portfolio returns were then added together to get a return series for the perturbed market portfolio, rebalancing after each period. Once the random perturbations were generated, they were added to their respective ideal portfolios as seen at the bottom of the screen. Finally, 50,000 sets of simulated portfolio returns were run for each of the 9 conditions. Now we need to look at the results of the 50,000 simulations for each condition in the next video.